Hello from the Forcetronics YouTube channel and welcome to building a Bluetooth, or better yet, a Bluetooth Low Energy or BLE to serial or UART bridge using an ESP32. So this video is all about how do we create a UART connection between two devices that is wireless using Bluetooth. Now I did a video on this that was pretty popular years ago, but in that video I used Bluetooth Classic. A lot of devices now today, including a lot of the newer ESP32 modules, no longer support Bluetooth Classic. So now I wanted to update this video or do a new video using BLE. Before I get started, I'll just mention, please support Forcetronics on Patreon, where you can find exclusive content, including the code we're going to review in this video. Check out Forcetronics collaboration, Anabit, at anabit.co. Anabit's all about data converters, analog to digital converters, or ADCs, and DACs. It's all about open source reference designs for making accurate measurements using ADCs or sourcing signals using DACs. It also has tutorials on data converters. It has its own YouTube channel, so check that out. If you haven't already, please subscribe to the Forcetronics YouTube channel. If you like what you see here, please hit the thumbs up. Let's get started. Okay, so most of this video is going to be spent with the demo and going over the code. I just wanted to start with this information that kind of explains the difference between classic Bluetooth versus BLE when trying to create a wireless UART or serial communication. Now, Bluetooth Classic used to have a built-in profile specifically for creating a wireless serial link. It was called SPP, or Serial Port Profile. So this was something it had in there. It was always connected. If you were to connect to a Windows device, you would see that this would show up in your COM port, which is where your true serial or UART connections show up. So it had this dedicated feature in it, which made it really easy to do UART over Bluetooth. But now BLE came along. And the whole idea of BLE came out years and years ago, but it came out just when sort of this IoT revolution was getting started. And the whole point of BLE was to add functionality to communicate with wireless sensors and things like that that might be battery powered. So it was really focused on reducing power consumption for battery powered devices. So it got rid of the SPP. But what BLE has a bunch of different features, but one of them is the GAT feature, which basically allows you to create generic services or user-defined services. So what happened was Nordic, the semiconductor company, created a service using GAT. GAT's almost like a Bluetooth API, where you could do sort of UART connection. Now, it's not a true UART connection in the sense that you will not see it on your COM port, but basically it uses BLE and GAT to create a Bluetooth connection where you can send UART data back and forth. But since it's not as robust or as built in as classic Bluetooth, there's a little more to the programming and the message handling, because now we're working with packets instead of a direct connection. But we'll see all that in the code. So next, let's see a demo of our wireless UART connection using BLE in action, and then we'll jump into the code. Okay, we're going to use, for our demo, we're going to load our code onto an ESP32-S3. And what I'm showing is actually one of Anabit's reference designs. So I'm going to do another quick commercial for Anabit. But the idea is this is the most accurate as far as measurement accuracy and highest resolution AIoT or IoT reference designer platform on the market. So besides the ESP32-S3, which is a powerful computing platform, it has this really good ADC that can support multiple channels. It's bipolar, so positive voltage, negative voltage measurements. It can measure down to microvolts, even hundreds or tens of nanovolts. So extremely good resolution and accuracy. It has other features such as an RGB LED. It has a quick connector. It also has the USB connector, so you can program the ESP32 from it. You can also do UART communication through the USB-C connector. And that's what brings us to this demo. So we're going to be running the code here. This is going to be advertising its Bluetooth name and connection. We're going to connect to it via my phone, which you see to the right. And that's going to be our wireless UART link. And then the communication to and from, the UART communication from my computer to and from the ESP32 is done through this USB-C connector. Okay, you could see my serial monitors open in the background and the code is already running. That's sort of the welcome message. Next, I want to show the app I'm using. So here's the information on the app I'm using for doing the UART communication over BLE. There's the name I'm going to advertise, FT Bridge. So first thing we want to do is connect to our ESP32. And there's the name, FT Bridge. We're connecting, we're connected. And you can see I already have a message typed into my serial monitor. Hello, how are you doing this fine day in Grand Junction? I'm going to hit enter, and we see it comes wirelessly from the computer to the ESP32, then over Bluetooth low energy to my phone. Now I'm going to type in a message from the phone. There's the message from the phone. Who dis be? I typed it in, went over BLE. Now I'm going to type another message back real quick, FT exclamation point or Forcetronics. There we go. And now we can see that on the phone. So we can see the communication going back and forth. I'm going to disconnect here. So I disconnect the phone from the Bluetooth connection. Now I'm going to type in another message, hit enter, and we see we get an error message that BLE is not connected. So let's look at the code now. Okay, here is the sketch, and you can see I have two local libraries for handling the BLE communication, Bridge, BLE, UART. I'll post all of this on Patreon. I'm going to scroll up where we have some notes. Here's the codes for the service Nordic created for the UART communication. So that's related to the GATT API, quote unquote API of the BLE protocol. Okay, here you can see I call the local library. I create the name that my Bluetooth device is going to advertise, which is what we saw in the video. Important function here is this callback function. So basically, this is going to get registered with a receive function in the library, and it almost acts like an interrupt where it's going to operate behind the scenes. So you won't call this. The library will call it when it receives data from a BLE device. In the demo, that was our phone, and then it's just going to write it to the serial monitor. In the setup, I start the serial communication, I delay so you can get your serial monitor open, I print out some messages, I then register the callback function, right? So this basically says, when you receive data to the BLE library, call this function, which is our callback function, and basically what it does is it just echoes that data to the serial monitor. Here we start the Bluetooth communication, and if it fails, we print out an error message. Then the main loop, and you can see the code is pretty simple. This task function handles the communication and advertising of our BLE connection on the ESP32. And then if I type data into the serial monitor, the loop is going to detect that by seeing that serial information is available. It's then going to load that into a buffer by reading it out. And then it's going to take that buffer, and if we're connected to a BLE device, it's going to send that information. Now, in the library, that information, if it's too long, will be broken up into different chunks. That's why you see this word chunking other places, and sent out. Because remember, BLE doesn't have a continuous connection like the old classic Bluetooth does for serial communication. So we send it out in chunks. If we're not connected, we're going to give this error message. So you can see, real simple. I'm going to preview the library, but I'm not going to go into detail in the library. Here is the .cpp file. We go up to the top. These are the main functions you need to worry about. The begin, self-explanatory. Task, that's going to handle the connections, the advertising. And then we have the send bytes, which is what we're using to send data to the BLE device we're connected to. And then on receive, this happens in the library in the background, and we gave it a callback function to write to the serial monitor. If you wanted, you could change that callback function to write the data somewhere else if you wanted to. You can see the various functions, and I have some notes by them. Here's the task function. Here's where the callback is being registered, things like that. Chunked, once again, is just referring to sort of packetizing the messages. And then here's the .h file. Here is the service codes again, and you can see we set them right away inside this constructor. So we're basically saying we want to use the UART service created by Nordic. Okay, that's it for building a Bluetooth or BLE to serial or UART bridge using the ESP32. You can find this code that we went over on my Patreon page. Check out anabit.co. If you like what you see here, please hit the thumbs up. Once again, if you have any questions, use the comment section. And if there's anything you think I missed or anything like that, please use the comment section. Thank you for watching.